Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today we'll be talking about Stegoceras, as well as, I think, a record amount of dinosaur news. We have 15 items.
But first, we want to say a quick thank you to our first patrons who have kindly pledged to I Know Dino and have helped us to start on our way to our first goal of raising enough money to buy new equipment. A few of you have mentioned in the past that sometimes it's a little bit difficult to hear us or to hear the people that we're interviewing, and we've been working on it, but it seems that the best way to handle it is to actually upgrade our equipment. So thank you to our first patrons. And for other listeners, if you would like to support us, then please visit our Patreon page. That's Patreon, patreon.com/iknowdino. And we've got a short little video that explains what Patreon's about and the goals and the rewards that we have, and hopefully answers any other questions.
So first in the news is an article that comes out of Nature's Scientific Reports titled Molecular Composition and Ultrastructure of Jurassic Peruvian Feathers. And it was written by Johan Lindgren and some others. So scientists have been trying to figure out what color dinosaur feathers were ever since they realized that dinosaurs had feathers. And up until about 2010, the conventional wisdom was that we might not ever find out because a lot of the signature proteins and indicators of what color something is don't really survive the fossilization process. As you know, fossilization completely replaces a lot of the material with various minerals, so it's never the same color as it was when it was fossilized. It usually turns black or, a dark stone color. It's not like, a feather gets fossilized and you pull it out and it's a bright blue feather or something. It's always just remnants of what it originally was. So there have been quite a few publications about the structure of melanosomes, and just for a little background, melanosomes are small cells that in mammal hair and bird feathers dictate the color of the hair and feathers. So scientists know that the rod-shaped eumelanosomes are found in black feathers, and circular phaeomelanosomes store pigment in red feathers. So what they do is they try to look for these different melanosomes under really high power magnification when they're looking into the structure of the feather. And in the past, they think that they may have found some of these melanosomes. Unfortunately, this technique won't work for some of the other colors, since they're caused by specific proteins that break down more easily rather than melanosomes, and they do not fossilize very well. But up until about 5 years ago, we weren't even thinking about melanosomes and the possibility of them fossilizing, so maybe they'll come up with some other way to find out if dinosaurs were ever bright yellow or pink or something. So melanosomes have been found on several fossilized dinosaur feathers, as I mentioned, but more cautious paleontologists and scientists pointed out that lots of bacteria is similar in shape to these melanosomes. It's basically just, if you've ever seen the shape of an E. coli or any of these kind of long, skinny bacteria, it's not really anything exciting. And then the other one that's just round. Shape alone doesn't really tell you too much. So there's a good point to be had there. So that's really where this article picks up. The scientists based in Lund University used chemical analysis in this case to test the area where they believed eumelanosomes were in a well-preserved fossil. So they started by removing samples from the plumage surfaces of their selected fossilized troodontid theropod, or avialin, depending on which research you prefer. Originally, most of the people were saying it was a troodontid, and now they're saying basically it could be a predecessor to a bird that wasn't really a dinosaur anymore. But in any event, it's got those feathers, still on that same path of feather evolution. So they picked the best looking samples that they could get out of this fossil, and they put them under an SEM, which is a scanning electron microscope, and they found something that they thought could potentially be eumelanosomes. So then they took some other samples and the same sample and all these samples and put them under a tunneling electron microscope, or TEM, and they looked at the structure of the potential feather, and they were pretty satisfied that it looked like a feather. It had the right pattern and the right structure and size and all that kind of stuff. But that's when they got into the new stuff. So they used time-of-flight secondary ion mass spectrometric imaging analysis, or TOF-SIMS, which we've mentioned before on this podcast, but you might not remember because it's quite a mouthful, as well as energy dispersive X-ray, or EDX, microanalysis. And they used those in combination with infrared microspectroscopic measurements, and they show all of these analyses, these chemical analyses, next to a known eumelanosome so that they could compare the chemical structure, and they got really good matches. Actually, some of those newer tools, like the time-of-flight SIMS, I hadn't really seen before I started reading some of these papers, but I did get into some infrared spectrometry when I was in college, and, we had to compare these different patterns to figure out what things were made out of, and the comparison that they show in there is pretty compelling. They do look really similar. So I think most scientists looking at it would say that it does look like a eumelanosome based on the chemistry. So then the scientists added a few more comments about how the structure matches melanosomes and not bacteria, and they use that with chemical evidence to say that they believe, quote, "Our integrated structural and direct chemical approach provides compelling evidence that eumelanosomes and endogenous eumelanin pigment are preserved in the feather remains of YFGP-T5199. That's the troodontid that I mentioned earlier. This result adds to a growing chronicle of molecular eumelanin detection in fossils and demonstrates the aptitude of rigorous experimental techniques for identifying ancient biomolecules and their use in characterizing quote-unquote paleocolors." So that's a really roundabout way of saying they think this bird had black feathers. Or pre-bird, or troodontid. But yeah, good science, shows some good progress in the understanding of colors. I really hope they figure out a way to find these other colors, even though now they're saying they can't. I would love to hear about a bright pink dinosaur, or bright blue or yellow or something, other than just red and black. Scientists in Wits University in South Africa believe that they might have the oldest dinosaur egg discovered to this point, which is about 200 million years old. And just a side note, researching this was incredibly frustrating because when you Google 200 million year old dinosaur egg, you get page after page of fake articles about a 200 million year old egg that some fool was claiming hatched in a Berlin museum because of a malfunctioning heating unit. I don't know, I guess it was supposed to be like Game of Thrones or something, and then a lot of people reposted it on Facebook and thought it was a real thing, and it's
so kind of like how Steven Spielberg hunted a triceratops.
Yeah. Oh man, it was frustrating. Come on, people. There aren't going to be hatching 200 million year old fossil. It's fossilized. It's not even a dinosaur. It's just... Anyway. But what the researchers are actually doing is they believe they have a Massospondylus egg, which was actually our dinosaur of the day last week, and they're sending it to France for a specialized X-ray analysis. And when I was reading it, I was wondering if they would also use some of the fancy CT scans or that awesome laser scanning technique, but I couldn't find any good information on that. They are hoping to learn more about the developmental stages that dinosaurs go through, and they want to model it all digitally so they get a better understanding of how dinosaurs developed in their eggs. So just a little caveat before this next piece. I know that it's not a real dinosaur, despite virtually every news source saying, "Dinosaur, dinosaur, dinosaur." This is not a dinosaur. It's really just a pterosaur, but I guess we'll give them a break. Specifically, there's an article published in Peer J titled "A Specimen of Ramphorhynchus," I'm not sure about the pronunciation, "with soft tissue preservation, stomach contents, and a putative coprolite." It was written by David Hone and others. So the abstracts say that they, quote, "describe a specimen held in the collections of the Royal Tyrrell Museum of Paleontology in Alberta, Canada, that shows both preservation and impressions of soft tissue, and also preserves material interpreted as stomach contents of vertebrae remains, and, uniquely, a putative coprolite. The specimen also preserves additional evidence for fibers in the uropatagium." So that was a lot of alsos in there, abstract. But basically what they're saying is they have skin impressions from this fossil. They have fossilized food that it was eating. Actually, it's fossilized right where its stomach would have been. They have fossilized poop. That's the coprolite. We've talked about that a lot in the past. And this is the first ever coprolite found in the pterosaur. And they have fibers from the area of the skin that stretches between its legs. If you're thinking, what kind of skin is there between legs? Pterosaurs and bats both have skin in that area, but I couldn't find any reference to birds having it, so I think it's kind of a unique feature to them. And they're loving this added information about the skin there because it's really rare to get an impression of it, and it makes a big difference in how the pterosaur would have flown, so it's giving them extra information there. So with that coprolite, the thing they're most excited about, and with the stomach remains, which are also really rare, is it gives them some insight into what this pterosaur would have eaten. But they couldn't figure out exactly what it was because it got kind of jumbled up in the stomach. But they found several vertebrae, so they know it was a vertebrate, which obviously means it was a carnivore, or at least an omnivore. And based on the teeth that it has, they're guessing that it was probably a fish. So it's pretty interesting. I'm not going to go any more in depth into it because we're not a pterosaur podcast, we're a dinosaur podcast. But it's so unique that I felt the need to mention it.
Next up is an update on Dippy, the famous Diplodocus from the London Natural History Museum. We've mentioned Dippy a few times before, starting with an episode on Diplodocus, where we talk about how there was a campaign briefly to try to save Dippy from being replaced in the London Natural History Museum by a blue whale skeleton, but that campaign didn't work, so now Dippy will be going on tour starting in 2018, and the Summerlee Museum in Coatbridge put in a bid to host Dippy for 4 months while it's on tour in the UK. And Dippy is 70 feet long and 16 feet tall, and in North Lanarkshire, where Summerlee is one of the few venues that's big enough to fit the dinosaur.
Over in one of our favorite dinosaur destinations, Dinosaur National Monument has reopened one of the favorite trails. So the Jones Hole Creek and the Jones Creek Trail were closed after a large rock slide in 2013. And since we weren't on the air in 2013, I'm going to go over what exactly happened then, because it was pretty crazy. So there were a couple of small slides in 2013, and then there was a huge one. The third slide involved a solid piece of sandstone that measured 100 by 50 by 10 feet, or 30 by 15 by 3 meters, that fell as a huge slab and then exploded into many smaller pieces when it hit a ledge partway down the cliff face. So one boulder broke off when it hit and exploded, and it was over 10 feet tall and 10 feet wide, and it, quote, came down off the cliff over 1,000 feet up and went 1,200 feet, a third of a kilometer, past the base of the cliff, end quote. That's a quote from National Park Service geomorphologist Bilderback. And he also said, quote, there's evidence of a lot of travel actually being through the air, so it would hit something and then it would be airborne, and then it would hit something and jump again, end quote. Finally, this huge rock crashed into a tree and landed blocking the trail, so that's basically why it's been closed since then. They waited for a while to make sure there weren't going to be any other major rock slides, and it appears to have calmed down, so that's why they're reopening it. They do have a sign posted at the monument boundary informing visitors that they're going to enter a potential falling rock area and should be alert of any sounds. And if they hear cracking or popping noises from the cliff face, they should immediately leave the area, which I guess is probably a good practice whenever you're next to a cliff. So they also said that there was evidence of this happening at least 2 other times in this spot in the past 1,000 or couple thousand years. And it made me wonder about other dinosaur excavation sites because a lot of times they're in sandstone or some other decaying and semi-fragile / precarious rock. And that's ultimately why they're sticking out of the ground anyway. You know, we talked about the fossilization process and how it has to get buried, and then it has to get buried in the right stuff, and then it has to get shoved back up above the ground, and things have to weather around it. So a lot of times they're excavating near these cliff faces, so I wonder if, they take any precautions, because it seems a little bit dangerous. So a little bit about the specific trail. The Jones Hole Trail is a popular attraction in the Dinosaur National Monument, and it's about a 4.25-mile trail that starts at the Jones Hole National Fish Hatchery, and it ends at the Green River. And apparently it's a really great place for fly fishing. Sabrina and I went hiking a little bit in Dinosaur National Monument up above the Green River, and it is a really scenic spot, so I could see why it's so popular.
And speaking of Dinosaur National Monument, in Utah, Congressman Jason Chavez and Rob Bishop are pushing to turn Dinosaur National Monument into a national park, and this would protect about 2,000 acres. The bill is being drafted, though the representatives are already anticipating it to be a quote-unquote tough sell, because it would mean that the president could not designate future national monuments in any of the 7 counties that are going to be mentioned in the initiative. So it'll be interesting to see, but it would be nice also if Dinosaur National Monument does become a national park.
Yeah, I kind of wondered why it's called a national monument, because it's pretty much a park. It's not really a monument. It's a huge area. It's a lot of trees, rivers, all that kind of stuff.
Hiking trails.
Yeah, it must be a lot easier to make a national monument than make a national park. So the representatives say, quote, "It's really an amazing part of history right down in Emery County. They'd like more dollars, more protection, more promotion, and to bring in more scientists from around the world, which will help the local economy. Sounds like a win-win," end quote.
I believe they'll be introducing the bill sometime this month, so we will be following that story and keep you posted on the status of Dinosaur National Monument. For anyone interested in learning more or using more of Adobe's Illustrator, Dribbble has a fun tutorial that shows you how to make a dinosaur-themed poster. It's for a fictional design brief for the London Natural History Museum, and you end up creating a dinosaur traveling exhibit poster. And this could be a fun way to polish up your Illustrator skills if you're interested, and we'll post a link on our blog to the tutorial.
Next in the news is one of our favorite topics, reconstructions of dinosaurs. Specifically, the one we're going to talk about today is Charlie Mcgrady's studio. So the studio is in Ben Eld, Illinois, where they make very accurate reproductions of dinosaurs. And the town is actually only of 1,500 people, so it's pretty interesting that they have such a big dinosaur manufacturing studio there. Their tagline is, quote, "For all your dinosaur needs," which is pretty awesome. I kind of wish we had come up with that for our podcast. I guess they already had it taken. There's a great video produced by Enjoy Illinois and the Illinois Obscura Society where they show the construction process. So his reproductions end up all over the world, and he says he's made about 25 different species, the largest being a 40-foot-long T-Rex, and they all look pretty great from the video. They're definitely museum quality. He works with paleontologists and/or consultants to get a good skeletal outline and a good pose for the dinosaurs. And if necessary, he'll make a small-scale model that's sent to the museum for approval. Then they sculpt the full-size dinosaur out of clay. Then they make it out of silicone rubber. And finally, they apply plastics to the mold and get it all put together. The process of putting it together with all the pieces he likens to putting together an automobile due to the fact that he uses a steel frame inside it to fit it all together. And then finally there's a new step that they're starting to get into, which is adding feathers. And this is a whole other ball game because you can't sculpt that with the rubber and the plastics that they're used to. So they basically all have to be added manually. And he says it's a lot like taxidermy at that point, the way you add all the feathers to a taxidermied bird or something. At the end of the video that we'll post a link to, he jokes that kids would be our best customers if they had any money, but most of their creations actually end up in museums. In fact, the pterodactyl that's right over Sue's head at the Field Museum is one of their creations. And it makes me want to buy one. I have a dinosaur need.
In Sugar Land, Texas, a woman with 2 T-Rex replicas in her front yard is being told by her homeowners association to take them down. An artist from Tucson made the figures by hand. The larger T-Rex is about 8 feet tall and named Holmes, and the smaller one is named Cassandra. The woman, Nancy Henschel, said she put the dinosaurs in her yard on August 21st, then shortly after got a letter from her HOA. Quote, "I knew I would trigger some response from the Homeowners Association. That's a solid reason why I did it," end quote. She said she did this to draw attention to the amount of control that HOAs have. Interestingly, some of her neighbors have asked to display the dinosaurs in their yards for a while, so Nancy came up with a creative solution to kind of spread the word and also give back. She's lending out her dinosaurs for 3 days at a time to neighbors who have proof that they have donated to a nonprofit organization for at least $50. So that's nice.
In Montana in the U.S., a paleontologist has just finished transporting a new specimen of a sauropod to his lab for further work. A lot of news reports are calling it a new dinosaur because there's some speculation that it might be a new species, but they really have no idea and they're all just full of baloney. They do know that it's from about 150 million years ago, and it appears to have been about 55 to 60 feet long, 18 feet tall, and maybe it weighed around 10 tons, but I'll get into it in a minute. They really don't know. So they excavated this specimen in kind of an unusual way. Nate Murphy, the paleontologist and founder of the Judith River Dinosaur Institute, who is the one that basically extracted the fossils, said, quote, "I usually take them out in the most manageable package. Some guys will even break stuff," end quote. And they do that just to make it easier to move, basically. But this time, he decided to take out the fossil in two huge pieces, weighing 3,500 and 5,000 pounds, or 1,600 and 2,300 kilograms. Then they encapsulated them in a lot of burlap and plaster, and they even hired a welder to support the entire structure because this plaster shape is kind of an amorphous blob. And Murphy says that the fossils are both as fragile as glass and incredibly heavy, so he had to get it supported just right, even though it was so heavy and difficult to move. So with all that steel added, it added another 800 pounds of scrap metal to the whole setup, getting it up near 10,000 pounds total. So that's quite a fossil to transport. It almost weighs as much as that dinosaur possibly did back then. He decided to use this technique because the bones are really intertwined, and he was worried about trying to split them apart, so they decided to excavate them in two huge pieces. The excavation took 3 years, and they got the fossils out of a ranch that Murphy and his crew has been working at for about 12 years. So far, the site has produced about 10 dinosaurs. 5 of them were Stegosaurus, and many of them may have been fossilized there from a massive flood that covered all the animals in thick mud. So excavating the individual fossilized bones from those two massive pieces of plaster burlap mess will take about 2 to 3 years, and Murphy said that he's going to use a sandblaster type machine that uses dental grade baking soda as an abrasive material in order to do the finishing work on it. I don't know if that's common or not, since we've never done that kind of work, but it sounds like an interesting way to blast away all that extra rock from a fossil. There's 2 really nice videos that show the huge pieces being loaded onto trucks, as well as the metal contraption that was built to support the fossils being removed when they finally got it to where they were going to do the lab work on the fossils. And we have links that we're posting for that too.
In Queensland, Australia, paleontologist Dr. Scott Hocknell and Sean Druitt, a content development manager from Queensland University of Technology, or QUT, are working together to create, quote, the world's most scientifically accurate collection of animations. And what they're doing is they're using fossils and what we know about modern birds and crocodiles to reconstruct movement and characteristics of dinosaurs, and they're using the same technology that video game creators use. These dinosaurs are programmed with natural instincts, and the plan is to have 10 animated dinosaurs in QUT's interactive display called The Cube, I believe at the end of this year. Because the dinosaurs are programmed to behave on instinct, the idea is that you'll be able to watch how these dinosaurs behave around each other, and it'll all be pretty organic, which is really cool. On a related note, listener Marky shared via email about this new beautiful game called Saurian, so thank you for that. It's a survival video game where players live like dinosaurs. Currently, the options are Archaeoraptor, Pachycephalosauris, Tyrannosaurus, and Triceratops, and the game takes place in the Hell Creek Formation. Marky said that the game developers recently updated the T-Rex model, and you can see it on their website. It looks amazing. And according to the website, the game is scientifically accurate. The team building the game is comprised of paleontology scholars and game designers, and they've done a lot of research and consulted with experts, including John R. Hutchinson, Matt Weddle, Denver Fowler, and Gregory Wilson. And what makes the game especially unique is the use of, quote, multi-agent reinforcement learning AI architecture. Quote, capable of learning on its own, this allows our AI to display unprecedentedly complex behavior in its interactions with players and other AI entities. Clever girl, end quote. The game is in pre-alpha, so there's lots of work still to be done, but it looks really exciting, and we'll post a link to it on our blog. And it seems like this game and also the QUT's display in the cube have a lot in common, so it'll be interesting to see, once these projects are done, how these dinosaurs work, since in both cases they seem to be behaving on instinct.
There's also a new documentary all about dinosaurs in prehistoric Britain that just started up on ITV in England. From the previews, it looks like a mix between Walking with Dinosaurs and Night at the Museum. Basically, it shows dinosaurs running around in modern Britain and a couple of hosts following them around talking about them and how ferocious they are and different facts about them. And at the same time, there's a bunch of other people that are running around terrified of the dinosaurs, otherwise interacting with them. So, kind of a weird idea for a show, but it looks like it's pretty well produced. So far, there have been 2 episodes, and I'm not sure how many there will be, but the first episode was on at the end of August, and then there was another one this first week of September. And like I said, it airs on the channel ITV in Britain and probably some other countries that get a lot of British channels, but we don't get it here in California in the US, so we're going to have to try to find another way to see it.
On October 20th, Jurassic World will be available on DVD, Blu-ray, and digital download, which is great news for anyone who wants to own it and then watch it at any time. To prepare for the release, Universal has created 8 featurettes, one which is called Bringing the Dinosaurs to Life, and it shows a behind-the-scenes look at how they filmed the movie. Basically, there were a mix of green screen, people acting as dinosaurs, and other visual cues for the actors to work off of as they pretended to be attacked by dinosaurs. And it's kind of amazing. You gain a lot of respect for their acting abilities. For example, one scene where Clara's in a truck or a medical van or something, and she's waiting for a signal that it'll be safe, and then I think it's a raptor comes in from the side and gets in her face and she's just screaming. And in this behind the scenes look, you see that there's just a green screen there and maybe a little board or something that shows her where she should be looking to pretend that the dinosaur is there. But she's still screaming her head off and sounds very terrified. And it's all, of course, very convincing. Nick Robinson and Ty Simpkins, who played Claire's nephews in the movie, said that it involved a lot of physical activity. There's a lot of jumping and running and picking themselves up off the ground. And we'll post a link on our blog so that you can see these clips for yourself. In Japan, there were some amazing dinosaur sculptures that were on display recently. Some of these were up to 16 feet tall. Specifically, this was at the Wara Art Festival in Niigata, Japan. They were created by a team of students from Musashino Art University, and they're made out of straw and just supported by a simple wooden frame. We'll post a link in our blog so you can see, but it's very impressive because it's just little pieces of straw, and yet it still looks very realistic. Not all the sculptures were of dinosaurs, but there was a T-Rex and a Triceratops, and they look fluffy and menacing at the same time. And there's photos of people standing next to them or in a T-Rex's mouth, and they just look really excited.
Yeah, they're very much kind of like an anime-style dinosaur, especially the T-Rex. Its head is so big that its jaw is resting on the ground, and then the top of its head must be at least 10 feet off the ground. And like Sabrina said, the opening is big enough that people would just kind of go and stand on the bottom jaw that's resting on the ground, and then they go like, yay, I'm in a T-Rex mouth. And it looks pretty awesome. In new museum news, there's a place called Dinosaur Center that's scheduled to open up in Cañon City in Colorado in the U.S. It's going to be called, quote, Royal Gorge Dinosaur Experience, end quote. And it's going to center around a 16,200 square foot museum. The total land area of the site is 39.5 acres, and it will include outdoor education and recreational opportunities. They say that there are going to be, quote, science-focused interactive displays, full-scale dinosaur fossil casts, skin-to-animatronic dinosaur exhibits, and hands-on exhibits with dinosaur fossils, as well as activities including a multi-story ropes course. I feel like more and more of these museums are including pretty extreme exercise and physical activity stuff for kids. Like we were talking about a rope wall and a zip line in a different dinosaur museum. I don't remember that when I was a kid. I remember a lot of signs and dioramas, but I guess it keeps kids engaged that way. So Canyon City has a deep, rich paleontological history that we want to celebrate and share with the world, said Zach Reynolds, director of Royal Gorge Dinosaur Experience, and it looks like this would be a great way to show it. Adult admission is going to be about $12, while the charge for kids 5 to 12 is $8, and then 4 and under are free.
And that wraps up the news, so now time for our dinosaur of the day, Stegoceras, which was a request from Will via email, so thank you, Will. Stegoceras means horned roof. It's a Pachycephalosaurid dinosaur that lived in North America during the Late Cretaceous, and it was first named in 1902 by Lawrence Lambe, though the bones were first found in 1889. And when Stegoceras was first discovered, scientists thought the bones were belly ribs, which were not found in other ornithischians, but now these bones are thought to be ossified tendons. The type species is Stegoceras validum, which is based on 40 specimens found in the Belly River group of Alberta, Canada. And between the 1920s to 1945, Stegoceras was actually thought to be Troodon, because they had similar teeth, but then better specimens of Stegoceras were found. Like many other dinosaur species, there used to be more Stegoceras species, and this includes Stegoceras lambi, Stegoceras sternbergi, and Stegoceras brev, but these were later assigned to other genera. In 1983, Stegoceras browni was renamed Ornithischians, but it's now actually considered to be a juvenile of Stegoceras validum, and this is based on an analysis of the cranial dome ontogeny. In 1990, Mark Goodwin described the skull of an adult Stegoceras, but the skull was large for Stegoceras. In 2003, Robert Sullivan wrote a review of the fossils found and thought that it was distinct enough to be named Hansuecia sternbergi. But a more recent study by Ryan Schott and David Evans argues that the skull is an adult Stegoceras, even though it lacked nodes in the back of the skull, which is seen on a younger Stegoceras. They're not sure why it doesn't have the nodes, but it's possible that this just changed with age. In 2011, a study in PLOS ONE called Cranial Ontogeny in Stegoceras validum, Dinosauria, Pachycephalosauria, a quantitative model of Pachycephalosaur dome growth and variation, showed that the skull changed with age, and Ornithischians browni was definitely a juvenile of Stegoceras validum. But also in 2011, a new valid species of Stegoceras was named by Stephen E. Jasinski and Robert M. Sullivan, called Stegoceras novomexicanum, based on 2 partial skulls. Stegoceras novomexicanum was only about 4 feet long compared to Stegoceras validum, which was over 6 feet long. Stegoceras in general is a more common, better-known pachycephalosaur, and it's part of the group Marginocephalia and Pachycephalosauria. They probably evolved from Hypsilophodon, which we talk about in episode 28, and bones have been found in Alberta, Canada, and New Mexico. Stegoceras validum was about 6.6 feet or 2 meters long and weighed 22 to 88 pounds or 10 to 40 kilograms, about 4 feet tall or 1.2 meters tall. Stegoceras was bipedal. It may have gone on all 4 feet, though, to look for plants to eat. They had small teeth that were curved with serrated edges, which again is similar to Troodon and why it was thought to be Troodon for so long. Their legs were 3 times longer than their arms, and they had an S or U-shaped neck. Stegoceras had round forward-facing eye sockets, so they probably had good vision and binocular vision, and it was possibly a herding dinosaur. Other dinosaurs that lived by Stegoceras included Albertosaurus, Maiasaura, T-Rex, Ankylosaurus, Parasaurolophus, Corythosaurus, and Dryptosaurus. Stegoceras had a large brain that was in a thick dome about 3 inches or 7.5 centimeters thick, and it was divided into 2 parts. The dome was smooth, and males had thicker domes than females, and older Stegoceras tended to have thicker domes than younger Stegoceras. In 1981, the Journal of Paleontology published a morphometric study of the cranium of the Pachycephalosaurid dinosaur Stegoceras, which measured the brain cases of 29 specimens and found that what was once thought to be 2 types of Stegoceras was just male and female, and that's when they found that males had thicker domes than females. Originally, scientists thought that male Stegoceras rammed their heads together like bighorn sheep or musk oxen, but in 1997, some paleontologists said that the dome was not large enough for that kind of impact, and it would not have worked unless the heads hit at just the right spot. Also, their head, neck, and body would have had to be in a horizontal line to transmit stress, but scientists think that their necks were S or U-shaped. An alternative is maybe they were flank butting instead, which involves moving the neck and rotating the head and not seriously trying to injure their opponent. They also had a bone rim above the eye that may have protected its eyes. And Mark Goodwin from the University of California, Berkeley, analyzed Pachycephalosaur skulls and found no evidence of healed scars, and he found that the skull bone is porous and fragile under pressure, so he said that they probably would have killed each other if they had participated in these fights. But in 2011, Snively and Theodore analyzed CT scans of Stegoceras validum skulls and found that they could have headbutted based on this extra layer of dense bone in the middle of the dome, which would have been extra protection. So Eric Snively and researchers published a study in PLOS ONE that showed that Stegoceras could have headbutted if it wanted. This was in the study called Common Functional Correlates of Head Strike Behavior in the Pachycephalosaur Stegoceras validum, Ornithischia dinosauria, and combative artiodactyls. It's a mouthful. So Eric and his team did CT scans on modern animal skulls in Stegoceras, then made a virtual simulation showing beasts going head-to-head, and they found that its brain was more protective than bighorn sheep and musk ox, again because of this extra layer of dense bone in the middle of its dome, in addition to a stiff rind outside with spongy material that can absorb energy and keep them conscious when they're butting heads. He also said there are, quote, alternating layers of stiff and compliant bone in the domes, almost as if they are wearing a double motorcycle helmet. So, Stegoceras may have butted heads. They may have done this to attract mates. Still, even though the study found that the domes could dissipate impact forces, it doesn't prove that they actually rammed their heads. They may have still flanked each other by swinging their heads into each other's sides instead. Stegoceras was a heavy breather. In 2014, Anatomical Record published Jason Bork and his team's study that showed that Stegoceras cooled its brain by breathing. It breathed like a bird or reptile and took long, deep breaths. This is based on a CT scan, and breathing helped cool its brain by cooling blood vessels in the brain. Also, Stegoceras may not have had nose hairs like modern reptiles, so they would have had a lot of mucus to avoid inhaling small airborne objects. Dinosaurs in general didn't have nose hairs, so they would have needed mucus.
Does that mean they had a lot of boogers?
Possibly. Jason Bork and his colleagues scanned the Stegoceras skull and found these things called turbinates. And these are intricate structures in the nose that help cool the blood and prevent water loss. They ran virtual air through a 3D model of the dinosaur's nose to see how the turbinates altered airflow. And that's how they found that it acted as a cooling system. So the air breathed in cooled the warm blood inside before flowing to the brain, which helped them keep cool when running away from predators, probably. Because dinosaurs were so large, overheating would have been a major issue. Although Stegoceras is a relatively small dinosaur, this still would have cooled its brain. Stegoceras also had a good sense of smell that it would have used to sniff out predators, mates, and food. I believe you can see Stegoceras in the first Land Before Time. They would have been the two dinosaurs that are headbutting, and Sarah, the Triceratops, accidentally gets in between them and runs away scared. They might be a Pachycephalosaur, though I couldn't confirm that. So again, Stegoceras is part of Marginocephalia, which means fringed heads, and that's a clade of ornithischians that were herbivores, both bipedal and quadrupedal, with bony ridges of frills at the back of the skull, and they lived in the Jurassic and Cretaceous. Stegoceras is also part of Pachycephalosauria, which means thick-headed lizards, which is also a clade of ornithischians, and they lived in the Late Cretaceous in North America and Asia. Pachycephalosaurs were herbivores with thick skulls, and they were all bipedal, and some had dome skulls while others were flat or wedge-shaped.
And our fun fact of the day goes back to the first news article when I was talking about melanosomes and the colors they make. Turns out that the pheomelanosomes that potentially stored pigments in dinosaurs' red feathers is the same as the pigment that makes my hair red. So I think that's a fun fact. And you can see my red hair on our Patreon page, where you can also donate and help us get better equipment, or possibly allow us to pay for subscriptions to scientific journals so we can get more accurate information, or even make more content and bonus episodes if we can reach enough milestone goals. So you can see all these goals and all of the rewards that you'll get for contributing to our Patreon page by going to patreon.com/iknowdino, and Patreon is spelled Patreon, and you probably know how to spell I Know Dino.
Thanks for listening, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur@iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.